Hi, my name is David Mason, and I want to show you an electronic device that I designed and built back in the mid-1990s in response to friends that I had working in calibration labs for the Navy. The complaint was that they were trying to test components that would get damaged by the instruments they used, and in essence there was no commercially available test gear for them to test these components. So I came up with a device that I would like to demonstrate. So the device that I designed and built back in the mid-90s is in essence a small oscilloscope that offers an XY display of active source on there. So it has a very small CRT. It's about 1 inches wide by maybe 3/4 inches high. The overall case height is maybe 1 3/4. The box itself is about 5 inches by 5 inches, not very big, and I don't even think this thing weighs 2 pounds. And it has unique features to it that other devices that do similar things aren't offering. This one has, instead of step relays, it uses solid state switching between intervals here. So the first step there, that would be 100 ohms per 45-degree angle, 1K ohm, 10K, 100K, and 1 meg. So it does the sweeping of that, and then I can switch the step intervals very fast. It also has variable frequency, so I can run from about 2 kilohertz at top frequency and bring it down to a very slow, just a couple of cycles per second. So it's a variable frequency on that display. And what's unique about this device is the CRT, or cathode ray tube, is a magnetically deflected CRT. So it's the kind that are used in television sets. And I managed to design a circuit to control it so that it would behave like a static deflection CRT that's used in oscilloscopes. So the device I'm about to test is a Hewlett-Packard Keysight Agilent model 11970W harmonic mixer. This extends the spectrum analyzer series from 75 gigahertz to 110 gigahertz. So it's very fast. This is a very expensive harmonic mixer. I'm going to show how I can test the mixer diodes within this harmonic mixer. And you see that V pattern, or that Z pattern? That is indicating that the diodes are good. If they were blown, we'd have either a flat line or just a vertical line. Had I connected this to a commercially available device, I would have blown it. The cost on this, believe it or not, is $5,000, and you can look it up if you don't believe me. So the next device I've got here is a capacitor, and I'm going to go ahead and sweep that capacitor, and we'll connect to it and look at the waveform we get from this. And we can see that it's a healthy capacitor. There's no leakage, there's nothing extraordinary about it, but it just shows that it's a working unit and can be used in any circuit. The next device here I have is just a resistor. It's a 1K resistor. You can see the step intervals. On the second step is the 1K per 45-degree angle, and the first one's 100 ohm per 45. So it's given you a vector display of resistance. I never pursued this device as a commercially available device. I researched the cost of components, but I recognized that there would probably be some real legal humps that I'd have to jump over and through, and that could cost hundreds of thousands of dollars, money I wouldn't want to spend doing any kind of a defense, even if I had won anything on there. So this device just became a lab use unit that I've used, and it's been very valuable, and I just wanted to let people see what this device was capable of doing.